This is ELEC 327 Lab 4 creating a Simon game with an MSP 430. Um, so, yeah, this week is Simon. We just have a simplified version of the game here because it's easier to set up before we have the full PCB. Anyways, let me show you how it works. Here on the breadboard, I have a takt switch, a capacitor, and an LED, and those are connected to the ground, pin 0, pin 1.0, and pin 1.3 on the MSP 430. So let me show you what happens when I plug this in. The LED immediately starts flashing into the game over mode, which I'll explain. So Simon uses a random number generator to decide on the next number, and the way I decided to generate pseudo-random numbers is dependent on user input, and so I kind of have to wait for a user to press a button before I can actually generate a purely random number. Otherwise, the first number in the sequence would always be the same, which I didn't want. So to begin the game, I set it into game over mode, and then press the button. It pauses for a second and then gives you a flash. 1, 2, 3, 4. You have to repeat the number on the button. 1, 2. Otherwise you lose. 4 again. 1, 2 again. 3 this time. 4. 2 this time, but 1, 2, 3. So I just did it incorrectly. You see the game over is triggered, and we are flashing again. And to reset the game with my code, you just press the button again, and it resets, and then you can play again. So that was 2. Oh, I hit it accidentally. 1, 2, 1, 2, 1, 1, 2, 3, 4. Okay, so this time I'm not going to hit it at all, just to show that it does in fact check. And there it breaks again. So, yeah, how the code works is it's relatively simple. You've got your main loop, which is the setup. You set up 2 clocks actually, so that you can read off the TA1R and TA0R counters. I add these together and generate a random number off those, so it's even more random. Then you also have to set up the interrupt on pin 3 where the button's attached to, and then set up pin 1.0 to output for the LED. Here we have the timer vector that interrupts every 500 or so. First it checks if it's game over or not, which to begin with it is, and it just starts flashing. If not, however, it checks a timer that's incremented every time that this interrupt occurs. This is basically just like the timer between when the random number is displayed, and you have until the amount of time that you have to hit the button the correct number of times. So it checks if the button count is the correct is the same as the random number, and then it tells you to go and generate another random number and continue with the game if it is. If it's not, the game over is set to true, and you get it looping again like that. Here's the button interrupt. So clear the button flag. take the current value of the TA0R register, which is counting up with a clock. This is used in the random generation, which I'll show you in a second. You increment, keep track of how many times the button's been kept. I also gave you some extra time on the timer if you press a button. Just felt nice. And there's also a reset clause in here. If game over is false and this is triggered, then it resets the game. Everything goes back to the start. Here's my random generator. It adds TA1R and the seed, which was the TA0R at the time of the button interrupt. Masks that to get the bottom 2 bits, and then adds 1. Which seems to work pretty well. Might change it up a bit though if I feel like it. The one other thing with this game is the debouncing. So tact switches have this tendency to bounce when they're pressed or released. There are software solutions, but they're not pretty at all. So we decided to go with a hardware solution, which is why there is a capacitor there. In the long run, the hardware solution saves energy because you're not triggering interrupt like twice as often or something to reset the flag of the button interrupt. However, in the short term, you have to pay for the capacitor to add on there, and it takes up more room on your circuit board. But otherwise, we definitely feel like the capacitor is a better in the long run. So yeah, that's Lab 4 of ELEC 327.